Hello there, class A. It's just me, Mr. Wee. So I do apologize I didn't get to this part or this section in calculus, but I had one more little thing to go over in 2-2. Last time we talked about horizontal asymptotes, so right now we're going to talk about vertical asymptotes. This shouldn't take as long, but you know me, I always kind of drag on the conversation longer than it needs to be. So what's a vertical asymptote going to look like? Let me first give you a function that is a vertical that will end up having a vertical asymptote, and I'll tell you some key features about vertical asymptotes. So for certain, this is going to have a vertical asymptote. And if you don't know what a vertical asymptote is, well, first let me describe what a horizontal asymptote is once again. Let's say you have a function, right? You'll never have this. This fails the vertical line test. But let's say you have this function, okay, and it goes off to positive infinity, and it rides like it rides along like maybe the x-axis forever and ever and ever. You know that the limit as this f of x approaches negative infinity, so the limit of this f of x approaches or positive infinity, you know that approaches zero, a y value of zero, meaning the height is going to eventually just be zero. Or you can have a horizontal asymptote that goes up along like you might have another horizontal asymptote that does this and just goes like this, and it goes off, and it seems like the limit as x approaches infinity of f of x, it seems to kind of, let's say that is a y value 4. Let's see if I can get a little bit of better focus in there. That'd be 4, right? That's a horizontal asymptote. Now think about what a vertical asymptote might look like. This would be a perfect example of a vertical asymptote. Like here, you have, let's say, I think, what is this? Let's see, a vertical asymptote. Maybe at some value, this sorry about this. At some value of this f of x function, let's say this is f of x. I mean, both of these things look like separate graphs, but they're part of the same equation. At some point, it goes off, not in the horizontal direction, but the vertical direction, all the way to infinity, right? That's a vertical asymptote, and we don't say that the limit is infinity. We just say there's a vertical asymptote at this point. So at this point, it happens to be at what, like 2. X is equal to 2, right? So here I'm asking you, at what value does this become infinity, or it just goes to infinity? Okay, so think about it, all right, about what can make this go to infinity while I give you the rules for vertical asymptotes. So here are some key things that you need to look for vertical asymptotes. You say, are there any numerical expressions / variables in the, actually, let's just cross this out. Are there any variables in the denominator? Just ask that of your equation, okay? That's the first one. Number 2, if there is, so let's do a dot here on the first one, and then the second step is a continuation of step 1, dot again. If there is, determine what your variable, like for example, x, like the variable x, right, cannot be. And what I mean is, let's look at this. In our function, do we have an actual variable in the bottom? Yeah, I see x squared. That's a variable. And is there any value of x that x cannot be for this whole equation? What your variable cannot be within this equation? Well, if you think about it, we can't have this go to infinity. I mean, well, you can, but I'm just saying, like, it wouldn't give you a real number, right? So what values really will do that? Well, I'll tell you this, it'd be positive 2 or negative 2. That's it. At positive 2 or negative 2, this function should go off into infinity, because if I plugged in positive 2, it'd be 2 squared minus 4, or I mean 2 squared would be 4 minus 4. 1 divided by 0 would be infinity. So let's check this out. So there's, in this case, your example is x going to be positive or minus 2, so it's both of that. And then these are your vertical asymptotes. Vertical asymptotes. Okay. So let me show you what's going to happen here. So why, and by the way, why is it that 1 divided by 0 gives me such a high number? Well, just think back. If you don't see the logic, think back to this here. Let's compare 1 divided by 8. If you translate that to a decimal point value, what would that be? I think that would be the 0. Actually, actually, I don't know. That'd be 0.0. I'm guessing it'd be 0.125. If I'm not mistaken. Yeah, it should be. 1 over 4 should give you 0.25. That's a quarter, right? 1/2 would be 0.5, right? Let's see here. 1 divided by 0 here. Let's see. What point am I trying to get at here? Okay. Oh. As you can probably tell, as your number gets closer and closer to 0, like 8 goes lower to 4 and it goes lower to 2, you notice the whole value inherently gets bigger, right? And you think of the closest number, if you can think of, let's actually try this instead. What if you divided 1 divided by 1, that'd be 1. What if you started going to decimals now, like actual decimals or fractions? 1 divided by 0.25, or it's the same thing as 1 over 1 over 4, right? Like really small numbers. We're getting closer and closer to 0. Punch that in your calculator, you're going to get 4, right? This should be of no surprise to you guys. How about 1 over 0.125, or basically 1 over 1 divided by 1 over 8? It's going to be 8. Well, as you get lower and lower in the number, I mean, like, we're talking fractions, okay? You're going to get much higher numbers very, very quickly. Like 1 over, I think, 1 divided by 125. I don't even know what that is. Let's just see what that's going to look like out of curiosity here. Okay, so let's turn this on here. Come on, buddy. All right, so let's go back. Okay, let's first divide 1 divided by 125 to see what that would give me in decimal values. Okay, let's see. That's 0.008. Let's divide that now, that answer. Second, this sign here. That's 125. So over here, I get 125, right? Expand this again. As you can see, as I'm getting closer and closer to 0, the number goes up pretty astronomically. So if I divide 1 divided by the number closest to 0, or basically at 0, it's going to give me an astronomical number that can't be quantified necessarily. So that's what gives me such a high value at a vertical asymptote. And for sure, let's take a look at what this is, and then I'm going to go over, like, I think one more example, and then that's it. So let's go to Desmos.com. I mean, I would normally graph this on your TI 83 or 84, but I want to actually show you on like a much more comprehensive and nicer graphing tool. So basically, as I'm saying this, just all you really need to know for vertical asymptotes to identify them is, does the bottom have, or does your denominator have a variable? That's it. That's pretty much it. If it has a variable, then, and you can find a value on the bottom that can go to like 0, you're pretty much done. You got a vertical asymptote, buddy. Okay. 1 divided by, let's say, x squared. What is it? Minus 4. Okay, look at that. So at -2 and 2, well, actually, look at this vertical asymptote. One side of it approaching from the negative side going to -2 goes up to positive infinity, and the opposite end, if you go to -2 coming from the positive side, so this is from the negative side, I'm sorry, from the left side, it goes to positive infinity. From the right side, the positive end goes to negative infinity. I know that's a bit of a tongue twister. Then at positive 2, if you come from the left side, which is the negative numbers from the left side, and you approach positive number 2, then your limit is now negative infinity. And the opposite of that is you approach positive 2 from the negative side, or the positive side. I'm getting my tongue's tied here. You go to positive infinity. See? Definitely vertical asymptotes. That's all you really need to see. Okay, so there you are. Okay, and let me give you a trigonometric function. And when you're like, wait, what? Trigonometric function? Just think back to like sine, cosine, and all that. Okay. What if you had a function that gave you the cotangent of x? And you're like, that doesn't really look like something that has a vertical asymptote, but expand this. What do we know about cotangent of x? Well, if you rewrote that, it could be rewritten as cosine of x over sine of x. See, does the bottom have a variable? Yes, it does. It has the sine of x. Which values of sine of x will give me 0? So if you think back to your unit circle, I remember sine of pi, or sine of 0 should give me 0. Sine of pi should give me 0. Sine of 2 pi should give me 0. The sine of, I believe it's is it 3/2 pi? No, it's not 3/2 pi. It's just 3 pi gives me 0. Do we see a trend here? Sine of 4 pi gives me 0. Okay. So you might want to check out your unit circle to see that if that's correct. But yes, these should be. So another way of saying this is x basically cannot be. You want to rewrite your vertical. You can write your vertical asymptote as x values of x that cannot be. X cannot be k times pi. You might actually see this in the solutions manual that x cannot be k times pi. What that means is, do you see how I can't just write x can't be equal pi? Because you're like, okay, I see that, but what about x can't equal 2 pi? X can't equal 3 pi. X can't equal 4 pi. You can individually write each one. X can equal pi. X can equal 2 pi. X can equal 3 pi. But then if you do ... it's like, well, some people are going to pick up on you're just adding pi each time, but most mathematicians don't like that. They're going to be like, well, you need to come up with a smarter way of saying this, that you're adding pi each time. So what they did is k. K, you just say x can equal k times pi, and then you define k as any integer. Any integer. And integers are basically whole values that aren't mixed numbers, like 1.2, like 1, 2, 3, 4. Those are all integers. Even -1, -2, -3, -4, -5. I believe, if I'm not mistaken, those are all integers. Just like sort of like whole numbers that don't have fractions or mixed decimals inside. Okay, so that's how you would figure out that. All right, guys, that's really all I have for vertical asymptotes. But that's basically all the gifts, or all the things I can kind of come up with. But I would give you guys some sample problems, but let's just stop right there for now. And maybe if I have time, I'll make another video, but I'm done for now. Okay, guys, good luck on the exam. Bye.